All right, guys, let's take a look at this. Oh, man. All right. Zach, I'm so evil. But remember, these are not going to count to your grade, right? But, you know, I am evil, so just get used to that. The big thing about percentages and decimals, what does the percent mean? Per 100. I love it. So listen to what I'm about to say. This is kind of nifty. The percent number will always be bigger than the decimal number because the percent number hasn't been divided by 100 yet, right? So how do you literally say this? You say 42.7 divided by 100. You guys with me? So it hasn't been divided yet. So of course it's always going to be the bigger number. Does that make any sense? Yeah. So for example, this one, since I'm looking at it, how do I write this as a decimal? Yes, because when you divide by 100, you move the decimal back twice. Our decimal places are based on 10, so multiplying and dividing by multiples of 10 is easy, because that's what our whole number system is based on. For some reason, it's based on 10. I have no idea why. 10 fingers. So if we had 8 fingers, it'd be very different. So this is 0.427. Very often I put a 0 there just so the point doesn't disappear, but it's not wrong if you don't. Okay. And then how do I say put that as a fraction? Let's just finish this row out. What place is this in? Thousands, right? So in my other class, I had some people a little confused about this. What place is the 2 in? Thousands. Hundreds. So to go from place to place, I divide by 10. And again, because it's based on. So every time I move over, it's division by 10. Tens, ones, 1/10ths, 1/100ths, 1,000ths, right? Start to get a list back here. So 0.427 is 427 thousandths. Kick ass. You guys with me? So I know a lot of you guys remember that. Some of us might have forgotten about that. That's how simple it is. It's just a base 10 number system. I like it. Yes? Are we okay? So decimals are just fractions where the bottom is a multiple of 10. So I have a better way to write it in our base 10 number system. I like it. So 3/5, if I can make it some amount of tens or hundreds or something, then I can write it easy. Did anybody do it that way? You could do long division, but why would you? What can you make 3/5 become?
60/100.
Sure. So you can multiply top and bottom by 20. You could also make it 6/10ths, the same thing. So 60 hundredths would be like this, right? Tenths, hundredths, is that cool? And then, of course, 60 hundredths is 60%. Kabam. Thickens the acid. And just in case you've never made the connection, what's half of 5? What's half of 5? So 60% of 5 is more than 2.5. It's actually 3. Right? That's all a fraction and a percent have in common is that. That is the percent of the bottom. That is the top. And I know that sounds really silly to some of us, but some of us maybe never thought of that. I don't know. Okay, this guy should be relatively easy now. What is he as a fraction?
64,000.
Yeah, he's thousandths again. And then what would he be as a percent?
6.4.
Bam, bam, 6.4. And by the way, I can't tell if it's a he or she. And then this guy, this is where our brains kind of tell us wrong. We're like, oh, that poor little thing's so small already. Yes?
For the 6%, does it matter if you put like a 0 behind the 6? Because I did that. I did
Whoa.
6.4. Like I just add that 0 there.
added it where?
Behind the 6.
Behind the 6 would change the meaning, right? If you wrote it as this, you mean, or something like that?
No.
Or like this?
Like
Like
0.6.4.
Oh, 6.4?
Yeah, I did that.
Oh, don't.
This-
Yeah. Because that 0 is sort of floating around. It's not just not needed, it actually makes it confusing.
Okay.
So why is this 0 here needed? To show where the 6, what place it's in, right? So when I write it like this, I don't need the 0 anymore. I already know the 6 is in the 1's place. Does that make sense? So you don't need that 0 in front of the 6 anymore. So don't write it. I like it. Kick ass. Okay, what about this guy? What would he be as a decimal?
0.0000.
Yeah, you got to move it once, twice. We got to add another 0 in there. So it'd be 0.0003. Kick ass. And of course, what place is that in?
10,000.
Yeah, holy shit. Tenths, hundredths, thousandths, 10,000ths. Definitely sound like it. Lilith. Okay, how are we doing so far? Is that all right? By the way, real quick. I don't like this as much as the explanation I gave earlier, but if you write decimal and percent like that in alphabetical order, to go from a decimal to a percent, you move the decimal that way. To go from a percessimal, I like that a lot.
Right.
I love that. To go from a percessimal to a descent. No, the Descent. Have you ever seen that movie? Oh, all right. To go from a percentage to a decimal, you move the decimal that way. Is that, you guys see that? But I kind of like better the percent number is bigger than the decimal number, so that tells you which way to go right there. Okay, maybe. I love some of your faces. You're all like, I don't know what you're saying at all, but just keep going. All right. Please let me know if you have a question, because if you have a question, at least 10 other people have the same question. And you could be their hero, if just for one day. What about this one? 1.12. What is that as a what do you call it? A percent. Let's do it that way.
112.
Kick ass. And 112% would be, as a fraction directly, 112 over 100. But what's another way to write that? It is also 1 and 12 hundredths. And of course, these are the same, because 100 times 1 plus 12 is 112. Is that cool? You guys with me? Okay. This would not make sense as the answer to a probability question. Are you guys with me? If you tell me the probability that it's going to rain tomorrow is 112%, what the hell does that mean? Does it mean the raindrops will be bigger than northern? Wow. It's going to rain so hard, it's going to be the next universe over. It's going to rain. Oh my God. You know. So probabilities, of course, go up to at most 100% chance. So when we get to the probability stuff and your answer is 270% chance of something, do not circle that shit. If you don't see where you went wrong, at least write, I know it shouldn't be this. I'll give you a point for that, you know, and take off some other points, but give you one more point than I normally would. I'm like, at least you know it shouldn't be that. Okay. But it does make sense for stuff like, couldn't I say that we made 112% more than we made last year? Of course, that's not a probability, it's an amount. That could be whatever, I can double, triple amounts. Yes?
You're ever going to want any of this simplified?
Oh, on a problem like this, we're not going to see a problem like this besides right now. But the funny thing is, if I was in like a math 88 or 90 class and I was doing this, I wouldn't want to see it simplified because they probably could be getting that out of the calculator. And the calculator gives it to you reduced. So that's how I can catch my people that are just using the calculator to do it. So in that case, I would not want it reduced. Yeah. Okay, there are a few different ways to do this problem. The most direct way to do it, now please, dear God, I've noticed this a lot. People will take this problem and write it like this. I didn't see that anybody do this. What is wrong with that? This would be 16 over 3, which is exactly not what that says, right? I'm seeing this more and more, and it makes me sadder and sadder. And I kind of understand, but not really, because that should be out of your system by now. Your brain says 16 don't fit in 3, right? But of course we know better. We're like, the answer is going to be way smaller than 1, brain. Just calm down. So the most direct way to do this is to just do this and go a little insane, right? That was, if you do this, what do you get? 1, 8, 7, 5. Okay, right? So that's totally acceptable, right? 1875. Another way to do that, let's see if you guys get this. 3/16 is 1/4 of 3/4. What does of mean in math? Multiply. Fewer and fewer people know this, right? And it's such a weird question. It's like, depends on your definition of is. So of in math means multiply. If I had 8 crates with 3 apples in each, 8 of those is 24 apples. Of means multiply, right? If I have 8 of these and they each have 3, 8 of those is 24. 1/2 of 1,000 is 500. 1/2 times 1,000, right? And again, if you're cool with the long division thing, you're awesome. But if Jeff, what are you? Let me see. What a great morning. So if I do 1/4 of 3/4, I could actually do this. That is 75% divided by 4. That's a much better division problem than 16 into 3. Are you guys with me? And conceptually, it's going to be the exact same answer. Or, how do I cut something in fourths? I cut it in half, and then I cut it in half again. So you can cut 75 in half, 37 and a half, and then cut it in half again, 18 3/4. Holy shit. You guys semi with me? A little bit? While I'm on this kick, while I'm on this division kick, do you guys know how to tell if this is divisible by 9? Yes? No? No?
You could divide less numbers.
No? What's 9 times 7?
63.
And what's 6 plus 3? 9. What's 9 times 5? What's 4 plus 5? 9. So if the digits add up to be 9, the whole thing is divisible by 9. Did anyone ever know that? I'm not saying that's true here. What do you get when you add those up? Man, that's good enough for government work. But when you add those up, what do you get? 24. Is that divisible by 9? No. So that number is not divisible by 9. But there's a similar problem for 3. 3 has a similar rule. If you add the digits and this divisible by 3, the whole thing is divisible by 3. So that is divisible by 3. You guys see that? Did anyone know that before today? Some of you guys. Yes, maybe? Some of you guys? The rest of you should be a little angry right now. Unless you think maybe it's a possibility you forgot it. But if you're really sure no one ever told you that, you should be pissed. You should be upset. So I know we all have calculators, but my God, is what I just said difficult? And isn't it useful? It is very useful. So what other numbers work like that? None of them. So 3 and 9 have similar rules, which makes sense because 3 goes into 9. What is the rule for 4? Here's my 5th puberty. What's the rule for 4? This number, somebody give me a number. Give me a single digit. 3. Somebody else give me another. 7. Give me another one. 9. Give me one more. 2. And then if I end it like this, that whole thing is divisible by 4. If the last 2 digits are divisible by 4, the whole thing is. Did anyone ever know that one? Yes? Okay, beautiful. Why does that work? Because 4 goes into 100. So 4 goes into 112, for example. Do you see? So 4 goes into 200. So 4 goes into 248. As long as the last 2 are divisible by 4, the whole thing is. You guys with me? Is this statistics? No. Is this useful? Yeah. And I hate that less people know this. It makes me sad. And you should be angry because this isn't hard, is it? But it would have been nice to know, right? Okay. I'm not purposely trying to make you angry, but And you all know 5 and 10, dear God, right? You all know how to tell something's divisible by 5. Okay. What about 6? 6 is interesting. What is 6 broken down into? How can you tell if something's divisible by 2? It has to be even. And how can you tell if something's divisible by 3? They have to all add it to be a multiple of 3. You guys with me? So if it's even and they add up to be a multiple of 3, that means it's divisible by 6 because it's divisible by 2 and 3, 6. You guys, is that cool? That is cool. What about 7? 7 has nothing. You're just, oh well. 8 is if the last 3 digits are divisible by 8, so it's a little less useful, right? But it's very similar to 4, which makes sense because 4 and 8 are related. Okay, I'll stop with that. Sorry, that's the end of that side note. How do I do number 2? Oh, I'm sorry. What is this as a percentage?
18.75.
Yeah. Okay, let's finish this guy up. What do I got? Now it's the real time now. Oh, shit. How do I start this off? Let's just do 2 more and then we'll finish it up tomorrow. Or not tomorrow. Yes, dear God. Yes. Right? Probability, the basic idea of probability is unbelievably simple. And this is percentage, but it actually is probability. It's the part out of the whole, right? The chances to get what I'm looking for divided by the total things that could happen. So 5 out of 40, which is 1/8, which some of you guys might know already, 0.125, so 12.5% chance. And again, 1/8 is 1/2 of 1/4, right? And 1/4 is 25%, so there's 12.5%. Okay, one more and then we'll head out. How do I solve this for x? What's the worst part about this equation? We'll get past that. The funny thing is, somebody pointed out it's better because I don't actually have to do shit. I'm going to do all the same stuff I would do to solve it. I just don't have to actually do it. Do you see what I'm saying? So what's the worst part about that besides that is the fact that there is a fraction, right? But it's an equation. I can kill the fraction. How do I kill division by sigma?
Multiply by sigma.
Multiply both sides by sigma so it cancels. So I get z sigma equals x minus mu.
And then plus.
And then add mu. So we get x is mu plus z sigma. If you didn't have it in that order, you're fine. That's the order that's an actual equation we're gonna use later. All right. Unfortunately, I'll finish this up tomorrow. That's the real time we gotta stop. Cool. I mean, not tomorrow, you know what I mean. Yeah, so bring it back obviously on Thursday. If you still have an issue to take care of, let me know. What's up?